Hello everyone, my name is Amir Aziz and I am BTech final year student from Lucknow University. My topic on seminar is shear wall. First we know what is shear wall. Shear wall are specifically important in high-rise buildings. In residential buildings, shear wall are external from a box which provides all the lateral support from the building. Resists lateral loads, seismic loads, vertical forces, reduces lateral sway of the building, provide large strength and stiffness to the building in the direction of their orientation. Rigid vertical diaphragm transfers the load into foundation. Introduction. Increase in the construction of tall building, both residential and commercial, and the modern trend is towards more tall structures. The effect of lateral loads like wind loads, earthquake loads and blast forces are attaining increasing importance. Almost every designer is faced with the problem of providing adequate strength and stability against the loads. Shear wall behavior depends upon material, wall thickness, wall length, wall positioning in building frame also. Architectural aspects. Shear wall provides large strength and stiffness which reduces lateral sway, reduces damage to structure and its contents. Overturning effects are large. Design of foundation requires special attention. Moment resistant frame must be provided along the other direction to resist strong earthquake effects. Special design checks are required in order to carry the horizontal earthquake force. Applications. Shear walls are not only designed to resist gravity loads but designed for lateral loads of earthquake or winds. Walls are structurally integrated with roof floors, diaphragms. Other lateral walls running across at right angles thereby are giving three-dimensional build stability for the building structures. Wall have to resist the uplift force caused by the pull of the winds. Wall have to resist the shear forces that try to pull the wall over. Wall have to resist the lateral forces of the winds that push the wall in and pull them away from the building. Shear wall structures system are more stable. Supporting area with total plans area of buildings is comparatively more, unlikely in the case of RCC framed structures. Functions of shear wall. Strength and stiffness. Strength shear walls must provide the necessary lateral strength to resist horizontal earthquake forces. When shear walls are strong enough, then they will transfer the horizontal force to the next element in the load path below them, such as the shear wall floors, foundation walls, slabs or footings. Stiffness. Shear wall also provide lateral stiffness to prevent the roof or floor above the excessive sideway. When shear walls are stiff enough, they will prevent floor and roof framing member from moving off their supports. Also, buildings that are sufficiently stiff with usual suffer less non-structural damage. As you can see in the diagram, two functions of the shear wall. Design of shear wall. A. The thickness of the shear wall should not be less than 150 mm to avoid usually thin sections. Second, the minimum reinforcement in the longitudinal and transverse direction in the plan of the wall should be taken as 0.0025 times the gross area in each direction. Uniform distribution. This helps in controlling the width of inclined cracks that are caused due to shear. If wall thickness exceeds 200 mm, the reinforcement should be provided in two layers. Each bars running in both the longitudinal and transverse direction in the plane of the wall. The use of shear reinforcement in two layers reduces fragmentation and premature deterioration of the concrete under cyclic loading. The maximum spacing of the reinforcement in either direction should be lesser than LW upon 5, 3TW and 450 mm, where LW is in horizontal length and TW is thickness of the wall web. Diameter should not exceed 1 upon 10th of the wall thickness of wall web. Force acting on shear wall. Shear wall resists two types of force, shear force and uplift force. Shear force are designed in stationary buildings by external forces like winds and waves. uplift forces greater on taller short walls and less on low long walls. Bearing walls have less uplift than non-bearing walls. Equal length shear wall should be placed symmetrically. It also provides an interior if exterior wall can't provide sufficient strength and stiffness. Comparison. Load bearing masonry is very brittle material. Due stresses such as shear, tension, torsion, etc., caused by the earthquake, the conventional unreinforced brick masonry instantly collapses during the unpredictable and sudden earthquakes. The RCC framed structures are slender when compared to shear wall concept of box like three-dimensional structure. It is possible to design the earthquake resistant RCC frame. It requires extraordinary skills at design, detailing and construction level which cannot be anticipated in all types of construction project. Even modernly designed shear wall structure not only more stable but also comparatively quite ductile. During very severe earthquake, they will not suddenly collapse cause of death of people. They give enough indicative warning such as widening structure, cracks, yielding rods, etc., offering most precious moment for people to run off structures. For structural purpose, we consider the exterior walls as the shear resisting walls. Forces from ceilings and roof diaphragms make their way to the outside along assumed paths, enter the walls and exit at the foundation. Advantages of shear wall. Thinner walls, light weights, fast construction time, fast performance, enough well distributed reinforcement, cost effectiveness, minimize damage to structure and non-structural elements. As you can see in pictures how the reinforcement is done and how making the shear wall is look like. Conclusion. The shear wall are also the most effective building elements in resisting lateral forces during earthquake. By constructing shear wall, damage due to effect of lateral forces due to earthquake and high winds can be minimized. Shear wall construction will provide large stiffness to the building, thereby reducing the damage to the structure and its content. Not only its strength in order to accommodate huge number of population in small area, tall structure with shear walls are considered to be more useful. Hence, a developing country like India, shear wall will be a backbone to our construction history. References. These are the names from where I have reference. And thank you.